We're good. We'll go ahead and get started. Thanks very much, everyone, for coming in here. I'm very excited to have a chance to talk to you today about application containers and microservices. First off, anyone here know what I mean when I say application container? Is that a term anyone familiar with? Okay, we've got some. How about Docker? People heard about Docker? Okay, good. We'll get rolling here. This is only a quick one. You only got 30 minutes. I'm going to go a little fast, but there'll be time for questions afterwards. I can stick around if there's any questions come up. First of all, who am I? My name is Andrew Weil. I am the Chief Information Security Officer at QTS Data Centers. If you don't know QTS, we are a full-spectrum data center services company. So we do private data centers, we do straight-up co-location, we do managed cloud services, managed IT services. I've been in the information security business for quite a while, but I started off in network engineering. So I started off routers, switches, doing all kinds of networking things. Began my career in the Army. I am a veteran of the Army. Was proud to be able to serve in the 82nd Airborne Division. And one key thing I want to share with you, I am not a software developer. I can maybe script on a good day, maybe, but I'm not a developer. So you might say, why is a person, if you're talking about application containers, if you're not a developer? We'll get into that, but it's because this new phenomenon about the way that applications are developed, deployed, and operated significantly impacts security. So I think it's really important for information security professionals to understand about application containers and microservices, what they bring, the challenges, the opportunities, and things to be aware of. So what we're going to talk about today, did the introduction already. We'll talk about what containers are and why people use them. We'll talk a little bit about software delivery and the whole microservices and DevOps revolutions. Get into a little bit about container security, some of the challenges, but also some of the opportunities that application containers bring for information security teams. And I'll leave you with some recommendations. And the last thing I'll talk about is just a little bit about a collaboration between NIST and the Cloud Security Alliance on the Container Security Working Group that I co-chair. So here's what I expect you'll leave with today. You'll understand some of the basic fundamentals about application containers. You will leave with, if you leave with nothing else, you will understand some of the differences between virtual machines and containers because they are not the same. We'll talk a bit about application containers and microservices, how they relate. We'll go over some of the security challenges and the advantages of using application containers, some best practices, and I will leave you with some resources to go out and learn more. So let's start off with hardware virtualization. A quick look back in time here, because virtualization has been very well understood and known for at least the last 10 years. And when we talk about virtualization, it's a technology that supports multiple operating systems running on one physical computer. Different kinds of virtualization, typically we talk about hosted or type 2, which is something like a VMware Fusion or an Oracle VirtualBox, where you are running the hypervisor on top of another operating system that's on top of the system, or what we call type 1 hypervisors or bare metal. Like VMware vSphere is an example of a type 1 hypervisor. KVM is another one. A virtual machine is a computing system that's running on that hypervisor, whether it be type 1 or type 2. So it's a guest system on the host. It's not aware necessarily that it's virtualized. Why do people virtualize? Those are 5 of the most common reasons. Everyone's seen these, heard these if you've been in the virtualization space. But and why do I have this up here? Because there's one key thing that's not up here. What is missing from here that everyone really cares about today, which is how do you develop and deploy software? There's nothing in virtualization here that makes things really any easier for developers. There is a new document that NIST has published, it's currently still in a draft state, that specifically provides definitions of application containers and system virtual machines. And you say, why is it important to have these published, documented definitions? So that we can all speak the same language and use common terms, which becomes very important when you're talking to different groups and trying to interface and look at different solutions. So let's take a quick look at what NIST defines as an application container. It's a construct to package and run an application on a shared operating system. That sounds kind of a little bit like virtualized machines because they are sharing physical resources, but I'll get into some of the specific differences. When we talk about a container, we're really talking about a kernel-level resource management facility. And I'll go into some of the details later about what are the resources that the kernel will manage through the container. But sometimes containers are called lightweight or OS-level virtualization. But it's not a virtual machine, and we'll give you some of the reasons why that is. The container creates a space for files and processes to operate that are isolated from the rest of the system. It's really important to understand that isolation exists, and that is something we'll talk about a bit when we talk about some of the security challenges with containers. It is about that isolation. Containers ensure the boundaries on system resources, and there are ways that is enforced, but essentially the boundaries are needed to ensure that one container doesn't starve resources from other containers. The containers are always configured to share resources with the system and other containers. The concept of a Linux container leverages two fundamental concepts that I'll touch on briefly here called namespaces and control groups or C groups. And if you've worked with Linux for a number of years, those aren't new constructs to you, you know what they are. When we talk about container solutions, there are many different forms of application container solutions you can go out and choose today. Docker is certainly the most popular one that's out there today, but it's not the only one. Rocket, even RKT from 4OS is another one. LXC, and then there are many others. And even Microsoft now offers a Windows container solution. So containers are gaining adoption, and they come in many different flavors. I told you one of the fundamental things I want you to leave with today is understanding the difference between virtual machines and containers. So I've got a little meme here. Containers are not virtual machines. Let's look at a depiction of what it is. Okay, so here you're looking at a virtual machine, and in the virtual machine, at the bottom of the stack, you've got infrastructure. This is your hardware. This is the CPU, the memory, the hard drive. This is what actually is the computer. On top of that, you've got an operating system. On top of the operating system, you have the hypervisor. The hypervisor is what performs the functions of allowing the different virtual machines to exist and share the resources. And then on top of the hypervisor, you have the different virtual machines. They're often referred to as guests. In each virtual machine, and this is a fundamental difference, and this is why I'm going into this, to compare and contrast against containers, is that each virtual machine has its own instance of the guest operating system. And on top of that operating system are all the binaries and libraries that are needed to run the applications that run in that virtual machine. So each one of those, across the stack there, you see the green, the orange, and the kind of reddish there. It could be 3 Windows machines, and you have 3 separate copies of Microsoft Windows running. It could be 3 Linux ones, it could be 2 in 1, any instance. They're completely separate, redundant, if they're the same instantiations of the operating system that are not connected. When you switch over to look at the same chart for what a container is, you'll see the infrastructure at the bottom. Again, this is the hardware, although containers can run on things beyond hardware, but for the sake of the depiction here, differentiating between a virtual machine, the infrastructure is the CPU, the memory, the hard drive, the storage, everything that's comprised, that's needed to run that computer. There's an operating system that's running on top of that. And then we have what's called, in this case, this is leveraging Docker, the Docker engine. And then above the Docker engine are the containers themselves. So in this case, the depiction here, we have 3 containers. Each container has the binaries and libraries, the applications that run inside that container require. And you'll notice in this case, there's just 3 applications, 1 application per container, but you can run a container with multiple applications inside of it. And the principal benefit here is that when you're developing an application, the container solution abstracts the operating system from the application. So this means I can take a container that I've developed, and inside the container I've packaged all the binaries and libraries that I need. But now I can move that from my MacBook to dev QA environment to a production environment, and it eliminates many of the dependencies that exist traditionally when you have deployed software in a monolithic environment where you have to package the application on top of the operating system. So the container abstracts the application from the operating system. This is why developers love containers so much, because they can build a container on their laptop, tweak it, work with it, fix the issues with it, and then it's very portable. They can share it with another developer. They can do the same thing and add value and fix things, but without having to be bogged down with the details of trying to get the operating system to work with the different binaries and libraries that are needed, and I need this edition and that version. This package simplifies software development tremendously. This is why it's gained and garnered so much attention and focus in the development community. So remember, a container is an implementation of operating system virtualization. It's abstracting the operating system from the application. When we talked about a virtual machine is abstracting the hardware from the operating system. So we've moved a bump up the stack, if you will, when we talk about containers. The application thinks it has a complete and independent implementation of the operating system, but that container engine is providing the resource sharing, the allocation, and the isolation between the containers. So a couple things to take away with. Containers are not virtual machines. Containers leverage abstraction of the operating system, whereas virtual machines level abstraction of the hardware. Here's a big one. Containers are run. You just go Docker run, and boom, your container is up in a matter of seconds. Virtual machines have to be booted. Even though operating systems have gotten much more efficient, and even though we have solid-state drives and things are much faster, it still takes tens of seconds to boot a virtual machine. A container will come up in single seconds. So how do you deploy containers? Well, you can deploy them on bare metal. You can buy a server, you can install the host operating system, and then you can install your container runtime engine, and then run your containers right on that. You can run containers in a virtual machine. So you can deploy a virtual machine that is running the host OS for your container system, put in your container engine, and run it that way. You can also go to the cloud. You can run containers on infrastructure as a service. You can go out to Amazon Web Services. You can build your own host, your container host, with the host operating system, deploy your container runtime engine, and then deploy your containers in your instance and in your infrastructure as a service offering. And lastly, another one of the very popular ones now is platform as a service. So you can go to AWS and you can build your own instance, or you can leverage AWS's Docker runtime environment, container runtime environment, where they take care of the operating system, and all you have to deal with is the container itself. And there are other platform as a service providers too. Joint has a big one. There are many out there. The point is, lots of different ways to run containers, whether it be on your MacBook, on your Windows machine, on a cloud, on a big server in your data center, lots of ways to run it. A couple of key terms that I want to cover this morning that are fundamental to understanding application container. We'll go through each one of these. So starting off with the host. The host is the physical or virtual machine with the operating system on which the container runtime environment executes, and then the containers exist in this environment and run on this. So apparently, from the conferences I've been to, you cannot do a talk on application containers unless you have a picture of a container ship. But it does make a good analogy here to really explain the different functions. The host is the underlying ship. Okay, so that is the virtual machine or the physical server upon which your container runtime environment is running. And the individual shipping containers are the different containers. So when we look at what is a container actually, you start off with a container image that you are actually going to execute. So the image is a read-only template that tells the runtime environment how to build your container. Container images are immutable, meaning that when you build your container image and you run it, the image doesn't change. Now you can change things in your container if you want, but that's not generally a best practice, and I'll talk about why later. But the images run to instantiate the container. So how do you get these images? Well, you can build one yourself from scratch. You can get an image from a public repository and update it yourself. Or you can download one and run one that someone else made. And I think based upon those three different ways that containers can come, that images come from, you can probably get to some of the security issues we're going to talk about in a little bit. A registry. So a registry is a way to store images. You can have private registries or public registries. If you have a public registry, you have access to the creative work of many other people, but you also have a concern of what do I know about this particular image? What do I know about the security of the image? What do I know about the components and the libraries and binaries that are inside of that image? If it comes from a public source, you may not have a significant amount of trust in that. Private registries are good for organizations that have established development organizations and are perhaps working on some proprietary development. Another key term when we talk about application containers is orchestration. So orchestration is not a term that's unique to application containers, but because of the advantages that application containers bring to the software and application development, deployment, and management process, orchestration is a key fundamental concept. This is the process and tools that are used to manage the deployment of the containers. Lots of different solutions out there to help with orchestration. So I've got some of the ones listed up here. These are not necessarily that much different from other orchestration solutions that are out there, Puppet, Chef, Ansible, but these particular ones are focused really exclusively on containers. Namespace. Again, this is not a unique term just to containers. This term has existed for a long time within operating systems, but the namespace is fundamental for application containers, particularly for the security thereof, because of the fact that namespace is one of the concepts that provides the container isolation to keep the processes and things in one container isolated from the other. In Docker, that runtime entry creates a namespace for each container, so each container has its own independent namespace. And there are 5 different kinds of namespaces. They're listed there: process, network, the IPC, mouse, and kernel isolation. Control groups, or C groups. This is another mechanism that's fundamental to application containers to manage where the namespace was providing isolation. Control groups is focused on resource allocation. So this is a way to share the host's fundamental hardware resources among the different containers, and the C groups can be used to control that, to govern how much access a container can have and how much of the CPU, RAM, or other hardware resources that the host offers to the containers can be used by any one container. Another one here, containers and networking. Okay? This is an area that is still evolving, it's still new, but the way that in most cases it's still working is that the default option when you leverage application containers, say Docker, is it is a local host bridge network. And typically, the containers are instantiated with RFC 1918 IPv4 address space out of a 172.17.16 block. And you're probably thinking, well, then how do you actually plumb the networking? It's a good bit of IP tables and NATing. There are options that have come about in the last couple of years regarding containers to make container networking and the management thereof easier. Weave, Flannel, and Contive are some of the big ones. There are many other ones too. And there are also now software-defined networking solutions just for containers. Okay, so that's some of the fundamental concepts and terms about application containers. I want to spend a couple of minutes talking about the evolution of software delivery, because I think this is important to understand, again, why containers have been adopted so enthusiastically by the development community, and how it changes the way that we know that applications are run. So in the 90s to the late 2000s, this was the era of bash scripts. The characteristics of this software delivery environment was where we had mutable infrastructure, meaning it changed rapidly. You would build something, and to the point here, the servers are considered pets. We even gave them names. When I worked at several offices in the late 90s and early 2000s, we had servers that were named after dead rock stars. So it's like, well, I'm going to go reboot Jimmy, and Janice needs to be patched, and we knew these systems. They stayed around for long periods of time. We took care of them, we patched them, we updated them. And there were significant differences between the different systems, particularly across environments. You could have the same application running in 2 different facilities, and the servers would really not be anything alike, because they would have been, perhaps this one was bought later, it's running on different hardware, it needed different drivers for that different hardware. Lots of different systems were not the same. And you typically deployed a few times a month if you were lucky and really good to make changes there. We get to the era of configuration management. We start talking about immutable infrastructure, but it really wasn't in the late 2000s, the current time period. We're we're starting to consider servers no longer pets. We don't name them, we don't expect them to be around very long, but we still have a lot of difference between our environments. We have more deployments, but they're still slow. And then the era of containers really finalizes the concept of immutable infrastructure, being you don't patch a container. When you need to make a change, you get a new container and you just kill off the other container. The operating system provides bare minimum, just the things absolutely needed to run the container. You put all your special dependencies and your packages and your binaries and libraries in the container itself, not in the operating system. And we're able to deploy as quickly as our continuous integration, continuous delivery pipeline can pump out a new image. So we can deploy very, very rapidly. So that based upon where we are, why containers? Well, a couple things. It really speeds up the software delivery. We now can have build pipelines that ensure consistent, immutable artifacts, and immutable artifacts have significant security benefits. If I know that it's not changing after I push it out, why wouldn't I push all my security checks into the build pipeline and do them up front before my image is released? For software deployment, we get common mechanisms and we can automate tremendously. Here's a visualization of the pipeline, the things that happen in a very basic sample pipeline. But you can see how you go from the developer on the left over to the Docker registry where we're going to store our container image. We go through this pipeline. The fundamental benefit the containers are bringing here is the ability to push these security checks and other quality checks into the build process. You don't release an image if it doesn't satisfy your check. So why is it really important that we get this message out to the information security community? Because the InfoSec community has to help the developers that are typically responsible for building this pipeline understand what things to check. So what are the things that we could check in the pipeline to ensure better and more secure applications coming out of the pipeline? Well, why wouldn't we do vulnerability checking inside the pipeline? If we know that the image is using certain binaries and libraries, why not script it and write some checks just during your build pipeline to look, does this component have any vulnerabilities? If it does, maybe I shouldn't be using it. Maybe it fails the pipeline, doesn't come out. Are there licensing concerns if you're using open source software components? Maybe you want to put those checks to make your legal team happier. But the point is, from what I've seen, in general, security teams are not engaging with the development community fast enough to get these checks automated and pushed into the build pipeline. InfoSec folks are still coming up to speed as to what is an application container. Meanwhile, the developers are full speed ahead, pedal to the metal, just racing ahead, automating as much as they can, and they are releasing software, and the developers in general are producing higher quality software, but not necessarily always more secure software, because they don't always know what they should be checking for. So, this is good for security, because by pushing the security checks into the deployment pipeline, we can enforce things not being released that have been validated and checked. Wouldn't it be nice to have significantly fewer vulnerabilities to patch after the fact if you could get those checks done in the pipeline and software was never released from the pipeline until known vulnerabilities were fixed? I mean, we know we're going to have to deal with vulnerabilities that are newly discovered later, but it sure would be great to know out of the box that Joe didn't enable SSL v2 as a default configuration coming out, and that's something we have to fix once it goes out into the dev or into the prod environment. So we can get full security scans, both black box and white box, done in the pipeline. Catch these issues before the software gets into the wild, and a side bonus, developers get to do this from their laptop. So we in the InfoSec world have the opportunity to engage the developer community. We're always complaining in InfoSec that we don't have enough resources, we don't have enough people, we can't hire enough people. Let's get the developers doing some of this. Let's get them doing what they do great, which is automating code, and have them help us by coding the security checks into their pipeline. Let's talk about some concerns. Here's another one of my security or container ship pictures here. Isolation. One of the biggest concerns, and this is not unique just to containers, we've had this discussion with virtual machines for a while. We've talked about the threat of folks escaping out of the guest host, or the guest VM. We've got a similar concern here on containers. We need to ensure that we have container-to-container isolation, that an event occurring in one container doesn't have the ability to impact the other container. And remember, I talked before about some of the features in containers that help ensure that isolation. Container-to-host isolation. This guy's having a bad day. We want to make sure that nothing that happens in the container can impact the host itself. Because if something in a container can impact the host, that threatens other containers that rely on that host as well, and then potentially other hosts in the environment too. Namespace is the key way to ensure container isolation. We want to make sure that the root user of a container should map to a non-root user on the host. Okay, and this is something new that when containers first came out, they didn't have this ability. And having your Docker daemon running without root privileges is a newer concept. It's important to make sure that your namespaces are configured in a way that you are ensuring that the root user of the container does not have root privileges on the host. Another concern in containers is that our traditional security controls may not work. So if we're used to leveraging network-based firewalls and network-based IDS and DLP, those controls may not work in a container environment. So we have to take a look at what's the objective of the control and how can we achieve that objective in a containerized environment. And then there is the concern about the new deployment model. We've got significant changes in the way the application software is being developed and deployed. This comes along with some changes in roles. We need to make sure that we understand the roles, that we've implemented best practices for role separation and for reduced privileges within the roles. So some quick recommendations here. Make sure your information security architects understand the fundamentals of containers and get them talking to the development team. I've been at 2 different companies now that are using containers, and at both of the companies, the development community has been, within that organization, has been very excited to talk about security and figure out how they can make their apps better. Giving them the opportunity to automate their checks means they have fewer bugs to fix later. It makes the developers happy. Make sure you harden your hosts, just like you would harden your VMware infrastructure and harden your ESXi hosts. You need to harden your container hosts. Follow best practices. Scan your container images in your CI/CD pipeline. There are many solutions out there for doing that. Docker has some free tools available to do that, and there are a host of other solutions out there that do that. Twistlock, Aqua, StackRox, even Tenable now has a container scanning solution. Follow the best practice recommendations. There are 2 listed here. You can go to the Center for Internet Security, and they recently added last year a benchmark just for containers. So that's a really good place to start if you're not sure what kind of settings you should be asking your developers about when they are hardening and working with containers. And also Docker has some best practice documents. And lastly, participate in the community. Here in Northern Virginia, we have a very active Docker meetup community. They meet about once every other month. I've been to a couple. They're great. They bring in speakers from Docker, from other folks. They talk about Docker containers. Sometimes they talk about security issues. It's a great way to learn more about containers. And the last thing I want to leave you with really is just to show you that NIST and the Cloud Security Alliance have partnered together to work towards developing a best practices document for application containers and microservices. If you're interested in this, participating, or learning more about it, come see me. I'd be happy to talk about it. So things you should do when you leave. If you're interested, get some time with containers. You can download Docker Toolbox and you can run Docker on your machine. They have a bunch of tutorials you can work through. You can kind of understand a bit more about the networking and how you instantiate a container. It's easy to do. There's lots of tutorials. Go out and talk with your DevOps engineering security team. Make sure that they're all talking together and understanding where your DevOps or development team is going with containers. Do you have exposures in your organization or concerns? Leverage the information that's out there for secure configurations. You don't have to do this yourself. And always look for ways to improve security. I mean, to me, this is a tremendous opportunity for the security community to get more checks done, to automate more, to leverage the capability of both the development community, what they're doing, and also automation. Make sure you consider your compliance requirements, because that may change your strategy for the use of containers. And also, don't forget about your need with your third parties. Okay? Are your critical third parties leveraging container technologies? And if they are, how have they secured them? Don't forget about your third parties. So that's what I've got. Thank you very much. Don't really have any time for questions, but you come see me. I'm happy to answer any. Next